The cloud business case. The cloud business case starts in economics, and yes, it's boring, but this is still something that you have to do. There are four different models. I'll briefly go through them. We have traditional internal IT, we have co-location, we have managed service, and we have cloud model. In traditional internal IT, you basically buy all the hardware and everything is capital expenditure. You pay upfront, and then you use them. That doesn't mean that you don't have operational costs. It's just that you also have to put up money up front to actually get your service in the first place. Co-location is similar in the sense that you also pay for the hardware, but rather than having to maintain the networks and power and cooling and all those kind of things, you pay for a service to provide that. Which also means that your servers are co-located with other companies. A managed service is similar to co-location in turn, but you also rent the servers and the networking hardware. So it's slightly easier, but it's still something that it takes time to get started with, because you have to negotiate first how many servers you need, and you need to make sure that your host procures those servers and sets them up for you, and then manages them for you. The cloud model is like in a managed service, but you rent virtualized resources, and therefore you pay for what you use, and it's much faster to set up a new machine and take it down again. The economic side of it then, this is an example straight from the book. I'm not sure I agree with it, but let's say you need a few firewalls and some commodity servers. You will also need, which we don't count in the example, room to keep the stuff in, internet connection, rack cabinets, network switches, cooling, load balancing, someone to manage the hardware, licenses for your software, etc., etc., etc. Licenses for the software you're going to need anyway, but everything else is things that you're going to have to worry about if you pay for this yourself. If we then just look at the servers and the firewalls, count with the depreciation over 3 years, we get to a cost, in this case, at €600 per month. Which may seem expensive, but since this is server hardware is more expensive than your regular desktop machine for reasons. The cloud business case instead is that since you are sharing the hardware resources and you only pay for the service when they're up and running, etc., you get away much cheaper. I'm not sure that the difference is this big, but that's at least what the books say. But they want you to use cloud, of course, so take it with a grain of salt, let's put it like that. More importantly, from a technical perspective, is that in order to understand if and how to set up your cloud environment, you need to understand what your requirements are. And in particular, your quality requirements. Some of them are more in focus than others. So looking at the ISO standard on quality requirements, this is a selection of requirements that may be of importance to you. So we have scalability, reliability, performance, security, privacy, and cost optimization. Let's go through them in some detail and discuss them a bit. But before we do that, it's important to know that the quality requirements are time dependent. So if you do traditional deployment, you would pick one service level, and you would aiming for where you want to be in, say, a couple of years' time, and you would aim for that and dimension your solution accordingly. But this would also be perhaps a trade-off. First of all, you will buy more service than you actually need right now, but it might also mean that you have too few servers for your peak hours. So you do a trade-off there. Now, in a cloud solution, you can always spin up more machines if you have planned peaks. So when you are looking at the cloud environment or a cloud setup, you need to view your quality requirements over time. So here's an example on scalability with your run-of-the-mill growth scenario. The blue line is the number of concurrent users per month, and the red lines are the number of concurrent users that you have in 1 year and in 2 years, respectively. According to this, you're growing more or less straight upwards. You can use this to predict how many servers will you need in after 1 year, and you'll see that you slightly more than double between year 1 and year 2. And you can dimension your server park accordingly. If we instead look at this per hour, we may see that this average number of concurrent users fluctuates rather wildly, anything from between 500 during the slump hours up to 8,000 during peak hours in 1 day. And this tells a completely different story. So when you look at the quality attributes, you need to look at them both in a long term, over a couple of months or a couple of years, and also in the short time, over 1 day. Because maybe you need to have resources that are available during those particular peak hours, in this case between 3 and 8 in the afternoon. You're going to need more servers than during the rest of the day, about twice as many, according to this. So, scalability. Things you can look for there is the maximum number of concurrent users and the medium number of concurrent users, and their maximum and medium acceptable response time. Burst rates and burst times, if you have them, like the peak hours in the graph before. Latency requirements that you also have. At any given point in time, this will influence the number of required servers you have, the computing powers of these, any requirements you have on bandwidth. So if you have more concurrent users or requirements on latency, for example, you're going to have other requirements on the bandwidth. Storage devices, the speed of them and the size of them will also be influenced by the scalability. Scalability long term as well as scalability within a 24-hour cycle or weekly cycle or monthly cycle, whichever is suitable for you. Reliability and availability. There are two sides to this. One is to take care of when things actually break, so failures, and making sure that you are monitoring your application and logging the health of it so that you can react quickly. And the other side is the planned reliability, so doing upgrades, for example, and also making sure that you, when accidents do happen, that you're able to come back to get up and running again. So backups, recovery, migration, and persistency, and all of those things. Backups in particular, you need to allocate storage space for that. If you take the standard setups that you get from some cloud providers, they may be suitable for your day-to-day operations, but if you want to keep daily backups, for example, then that puts other requirements, higher requirements on how much storage space that should be available. Should you have those backups on the same disk, or obviously not, but should you have them on a similar disk as where you're running your production service? Or should you also have them in some sort of glacier facility where you can get them, but it'll take more time? Distribution of your application over several data centers, so that if the data center goes down, your application can continue running. And load balancing, of course, then between your different data centers or your different servers within that one data center as well. One interesting aspect to look at here is what does the cloud provider promise in terms of uptime? And actually, when it comes to backups as well, that's a pretty exercise to look into different cloud providers of backup solutions and see what do they actually promise in terms of data persistency. I'm not sure you're going to be overly impressed of it. Performance, similar things as with scalability. Computing power, response times for storage, storage capacity, network bandwidth, and influences the same things: number of servers, computing powers, bandwidth requirements, and so on and so forth. So not much new here, because, well, scalability and performance tend to go hand in hand in these kind of applications. Security. Well, security of your data, so that it doesn't end up in the wrong hands. Security of your host, so that they don't get hacked, and security of the network, so that the network itself doesn't get hacked. And again, what does your cloud provider promise with storage persistency, for example? What services are provided to maintain your server platform? For example, security patches. If you are doing the installs yourself, then of course, obviously, you have to take care of patching security. But if you are buying a platform as a service, then that ought to be taken care of by the cloud provider. So what do they promise that they're going to do? Privacy. Privacy is it's gotten a lot of attention in the last year or so, but things to look out for here is, for example, where is your data stored? There are, for example, laws in many European countries that require that data about its citizens should be stored in that country. So that's one thing to look out for. In some cases, Amazon has been subpoenaed to hand over all your data to a court. So badly written court orders, so that disputes between company A and B, and you happen, just as company C, to also use Amazon, and then suddenly all your data becomes public in the court case between companies A and B, because of a badly written court order. That has happened, so you need to make sure that you watch yourself for that. And privacy is something that you can't really take a backseat approach to it. You have to be proactive. You need to make sure that you have a strategy for dealing with the privacy of your users. And while also doing that, you should also have a look at what does the cloud provider promise in terms of privacy. Normally they are rather good at promising that who gets access to the physical service and so on, but you still need to keep a look on it. So in summary, the cloud infrastructure that you need is determined by the quality requirements that you have, and you also need to make sure or look at the support structure around the service, monitoring, privacy, security, and so on, that the cloud provider offers to you. And all of this together should be used to base your decision about whether you are going to the cloud or not, and which cloud provider that you're going to use. All of this also determines what you must pay. So if you go for the cheapest option, you are less likely to get some of this infrastructure, some of this support structure that you would like to have. Arguing why you need a service level, looking at those quality requirements, and actually making sure that you are building a solution that will cater for the right things. That's part of your business case. And you should also have in mind always, so if you go to the cloud, you have a certain service level, you have a certain level on all of those quality requirements. And what is the alternative investment? What would it cost for you to do this by yourself?